Okay, it is already coming on the screen in some kind or the other. So I'll just start. What I'm going to talk about is really understanding the behavioral aspects of energy use, and then we use a network-based approach. So the top line is the psychology part, the second line is the statistics. And what we want to do is, of course, we all know that anthroposophic climate change is a problem, and also reducing energy use reduces your energy bill, and saving money is nice even if you don't believe in climate change. So we want to know how can we influence people such that they limit their energy use, and we specifically in this study focus on electricity use. And of course, before we can influence people to change their energy, we need to know what the energy behavior is. So that's what I'm going to talk about. As I already mentioned, it's joint work with Linda and also Lise Stech from that group, and our PhD students Mark and Nitin. And I'm going to present a case study from Buurkracht. Buurkracht is a Dutch energy community initiative. And there has been already quite a lot of research on energy use and what behavior, what intentions, what norms, etc. drives energy use, but that always had been on an individual level. So just studies where you try to measure individual properties and see how they relate to energy use. But of course there's more to that. People don't live in isolation, they live in a community. And maybe if a person in the street is doing all kind of stuff like installing solar panels, his neighbors might think, hey, that's a good idea, let's do that as well. So Buurkracht is specifically designed as a community initiative where we say, if communities work together, can we improve things? So to find out how this all works, we really need to combine a lot of psychological theories with sociological theories. For instance, we've got this theory of planned behavior, where we say how intentions influence behavior. There's the value belief norm theory, which is exactly what it's called. Values influence beliefs, they influence norms, and that influences behavior. The norm activation theory saying, okay, this actually only works if people understand the consequences of their behavior, etc. We've got a few other models over there, for instance, also the gateway belief model, saying that support for climate change policies, when do people support that? If they understand the consequences, really get the impression I can do something about that, etc. There are some collective sociological models in there. So in total, a lot of different models. All these models require us to measure a number of variables from people. So we had a sample of, let me look up the numbers, about 700 people that participated in this sample, and the 700 people, they were divided into two groups. One were the initiative participants. They really participated in the Buurkracht initiative and they received certain interventions. And the other half were was kind of the control group, the right door neighbors. So they lived in more or less the same kind of house, had the same kind of demographics, etc. But they did not themselves participate in the initiatives, but their neighbors did, and we also wanted to see how does that work for them. So we have all these theories, and for all those theories we had to collect data. So for instance, the first theory is a theory on three variables, personal norm 1, personal norm 2, and behavior. And the theory says, well, x1, x2 relate like this, x1, x3 like that, x2, x3 like that. That's all fine, and we could measure those three, do our model in the classic way, and we're done. But we have another theory focusing at x3, 4, 5, 6. So x3 is part of both sets of theories, and again, we have a number of colored squares where we have theory about. And another theory looking at 6, 7, 8, 9, but also variable 2. And you can go on like that. We have a really something like 10 different theories, so another one. And all these colored cells we have kind of hypotheses about, and we are going to collect data on these 700 people to validate our research hypothesis. But if we collect all these 10 variables in this picture, it's 10 variables, but we actually collected 65 variables, then we not only collect information on these colored cells, but also, as a kind of added bonus, information on all the cells that are now yellow. So suddenly, even though we were not primarily interested in this, we had a relation between variable 1 and variable 10 in the top right corner. So not only do we want to do confirmatory research on the cells that were in non-yellow colors, we also want to explore what else is going on in our data. So we collected the data, and if you want to look at relations, what you can simply do is look at the correlation table. This is the correlation table, 65 by 65. It got all the answers that you need. So if you are a robot, you can stop here. But I don't think we are robots. At least I cannot make much sense out of this. So the next step is, how can we understand what's going on here? If it's a small data set with 3, 4, 5 variables, something like this works perfectly fine. But for these large-scale studies, this simply doesn't work. So what we do is we visualize the correlations. And in order to explain that, I move to a smaller example, just a toy example. We've got 4 variables here. They correlate with each other in a certain way. And the picture below shows those 4 variables, and then the green lines indicate the correlations. The stronger the correlation, the thicker and the darker the green color, and the lighter the correlation, the smaller the correlation, the lighter the color is. But what you see is still not very helpful, because if I would do that picture on the left with 65 variables, you see a lot of green lines, and that's still not helpful. The problem is that in psychology, everything is related to everything, or almost everything to almost everything. You simply see too many lines. So what we do is we move from correlations to partial correlations. Partial correlations are the correlations between 2 variables when you kind of filter out all the information that is in all the other variables. And once you do that, you suddenly see that a number of lines are disappearing. Then we do a few additional smart mathematical tricks to say, okay, all the correlations that are close to 0, let's just not draw them because they are not too interesting anyway. And you end up with a network of variables that are indicating which is related to which. And what we can, for instance, see is that x3 at the bottom here seems to be some kind of central variable because it's connected to all the other variables, and x1 and x4, for instance, are not connected to each other, only through other variables, but they don't have a direct link. So this is the network theory. It started about 8 years ago by Angelique Kramer and Danny Borsboom. It resembles social network theory, but it has a few differences, mainly that here our variables are variables rather than fixed values. So the statistical theory is quite new in that sense, and we can do nice things with it. So if we look at the correlation table again, but now in the form of a network, we see this picture. Of course, this picture is still, if you look at it in the first 5 seconds, you don't understand directly what's going on. That will never happen if you have 65 variables. There's simply too much information. But I can guide you through it a bit. What we did is we made smart use of color. So for instance, here we've got 4 variables, all of the same color. And that means that those 4 variables all belong, we hope, to kind of the same scale. So they all measure the same construct. These 4 are all altruistic variables, so different types of altruistic variables. And what we see, if we look at the green lines that are the connections between the variables, is that every time we look inside a single color, all the variables are very strongly related to each other. So that validates that all the variables are measuring the same construct. Whereas if you look at lines between different colors, there are lines, but not as many as within a single color. So this is kind of a visual way of doing a Cronbach alpha, just test validation. We have a scale on top here, and we see that all those nodes, or almost all of them, are strongly related to each other. So they all more or less measure the same thing. So we can reduce the complexity by saying, well, if they all more or less measure the same thing, why not simply look at their mean or sum score or something like that? And then you get a picture like this. So this still is the same Buurkracht data, but then from 65 variables brought down to 22, which is a much lower number, much easier to comprehend. And the nice thing here is that you see that there are only a few lines remaining, and it's almost even kind of a pathway that you see, okay, if I want to go from down here, for instance, 16, the altruistic variables, and I want to go to 1 and 2, which are the sustainable energy intentions. So do you have the intention to save energy? You see that you only get there through a number of in between variables. So that really shows the route you need to take if you want to influence energy use. And it also shows that the number of relations are simply not that interesting. For instance, 13 is not connected to anything. That's the need to belong in the group. Might be important for a lot of reasons, but not if you want to influence someone's electricity usage. So this kind of confirms, if you would put this picture next to one of the first slides I had with all these different theories, the theory of planned behavior, the gateway belief model, etc. All those theories are more or less confirmed by this picture. And on top of that, I said we have all these yellow cells. Is something interesting going on there? And actually not too much is going on there. I think, for instance, this small line over here, but that's just a small line, could be coincidence, could be something. So sometimes you find something and can build new theory on top of that. But this is really a nice exploratory tool to think about these things. Then one last remark about this data set. We had two groups, the people that participated and that we really intervened, and also the right door neighbors. And the goal of the whole Buurkracht study was to find out whether it was possible to influence people without intervening them directly, but by intervening people in their neighborhood. What we see over here on the left is the network of the participants, on the right of the non-participants. And you can do a visual check and see, okay, it's more or less the same network. It's not exactly the same network. For instance, there's a line over there between 21 and 17 on the right, not on the left. So it's not exactly the same, but it's close enough. You can do some formal statistical text to compare both of them, but not in 12 minutes. And we can indeed confirm that the networks are not statistically different from each other. So what I hopefully shown today in this short presentation is that these kind of network models are quite valuable for at least three purposes. You can use them for scale validation, so the Cronbach alpha type of calculations. You can use them for confirmatory research if you have a large-scale data set with hypotheses from multiple theories. You can confirm all of them using the network approach, but you can also use it to explore what else is in your data, something which is really difficult if you only look at your correlation table, because that's simply too many numbers. So thank you for your attention.